Hi and welcome to Unit 2, Topic 1, Video 2. In this video we're going to look at how to find missing sides in triangles using trigonometry. Okay, so I've got 4 examples here I want to run through with you. They're pretty quick and there's reasons why I picked them all. You'll notice I'm a boring math teacher. X, 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 but it could be Y, it could be A, it could be anything. I've just chosen to use X just to keep it simple and not focus on that. Now I almost put in an example where I left out the right angle, but I couldn't find a way of making it obvious that you couldn't have a right angle triangle without putting too much information in the question. But the first step to solving any trig equation or trig question is to take a moment and just make sure you're actually dealing with the right constraints. Is it a right angle triangle? Do I have an angle provided? Is the information there that I need to deal with? Make sure that you're okay with that. Anyway, that will become important in one of these examples. But let's start here, work down, see how we go. So we need to find x in this triangle. It is a right angle triangle. I do have an angle and I can identify the sides. So this is obviously my opposite. It's opposite the 11. This is my hypotenuse. Right angle works. I go to my SOHCAHTOA and I recognise that sine of theta is equal to opposite over hypotenuse. That's what I want to work with. And now I'm going to put in the information I have. I have the opposite and the hypotenuse. So I've got sine of 11 is equal to 10 over x. And now I need to solve this. So this is actually one of our more difficult variations. If the unknown is in the denominator, it's a little bit trickier. It's an extra step. It's not bad, but you just need to make sure that you follow mathematically the rearrangement structures. So we get x sine 11 is equal to 10. Just multiply both sides by x. And then I'm going to divide both sides by sine 11. And I get x is equal to 10 over sine 11. Get my trusty calculator out, make sure it's in degrees. 10 divided by sine 11 is equal to 52.408. So this is equal to 52.40843 ... and I'm going to round that to 52.41. I haven't given you any units for any questions, so we'll leave it units, but you might need to put centimetres or something on there. Now it's important to recognise here that we want to keep our accuracy throughout the question. So I've written down more decimal places, maybe I should write them all down, but then I've rounded at the end of the question, so 2 decimal place rounding is appropriate at the end of a question. So there we have it. That's the solution to our first example. Is it reasonable that that's so much bigger than this? It doesn't look like it is. Maybe it's twice as big. Well, we need to recognise here that the diagram is not to scale. That is not 11 degrees. 11 degrees would be a lot flatter, and that would give you a much larger proportion or ratio between the hypotenuse and the opposite. So let's go on to question 2 now. So this question, do we have all the information we need? Right angle, an angle? An angle? No, we don't have all the information we need. So instead, what I'm going to do is consider other things I've learnt in the past that might be helpful here. Pythagoras Theorem, of course. I know 2 sides and I need the third, and it's a right angle triangle. So this is just a bit of a review quickly. The hypotenuse is the one that I usually call C, and I can call this A and B in any order. And so Pythagoras Theorem is that A squared plus B squared equals C squared. And so we get 4 squared plus 5 squared equals C squared. 16 plus 25 equals C squared. C squared equals 41. I've done a little swapperoo there. C is equal to the square root of 41, whatever I get from that. And that might be off the screen. I'm sorry if it is. But the square root of 41 is 6.403124237 ... And that is, because I'm pretty sure I'm off the screen now, so I'm going to be really dodgy and just move it up. That's about 6.40 to 2 decimal places, because remember in general maths, the expectation, unless you're otherwise told, is to use 2 decimal places. Okay, let's have a look at our third example, although it's not labelled as such. I need to find x. I've got a right angle. I have got one of the angles. I've got this side here. Now 41 is there, which means that this is my adjacent and this is my hypotenuse. So I go back to the old SOHCAHTOA and I can see that I'm dealing with a cos of theta is equal to adjacent over hypotenuse. It's this step here is where a lot of students get it wrong. See this a lot, where they just misinterpret which ratio to use, and it's a real shame because there's so good credit here if you just make sure that you're really consistently getting that right. Now I'm going to substitute the values I know in. This is my theta as well. So I get cos 41 is equal to x over 11. I multiply by 11. I get 11 cos 41 is equal to x. Pop that in here. And I get x is equal to 8.301805 ... And that's approximately equal to 8.30. Again, 2 decimal places because that's expected, even if that leaves it with a 0 in the end. Now you'll notice here just a little bit of a tip, bit of advice, that we either end up with like this question where you do one of the side lengths divided by sine of the angle or cos of the angle or whatever, or you end up with one of the side lengths multiplied by it. And another big mistake is people just incorrectly rearrange and get to the wrong thing. There's a big key here though. My hypotenuse is 11. If I muck that up, I'm going to get something like 14 or 15 here, which cannot be the adjacent side. Always look at that number and go, is it appropriate? If I'm calculating the hypotenuse, is it larger than the side I was given? Yes. If I'm calculating a shorter side, is it shorter than the hypotenuse? Yes. The only time you've got a problem with that way of checking is if you're dealing with the two shorter sides. We don't know which one should be bigger. But of course, we kind of know because this is 41 degrees, which means this is 49. So that means that this side here should be a little bit bigger than this one. Otherwise, they don't match up the angles. So you've got lots of ways of checking. Anyway, let's have a look at this last example now. I've got x up here, so there's my x. I've got an angle and I've got a right angle. So this is my theta, which means that this is my adjacent. And then I don't have another side. So this is a bit of an issue. I need another side to be able to use and apply trigonometry. I can see it's going to be either tan or cos of theta to get my adjacent, but I don't know what it's going to be. But I can find this side. So what if I call this y? I've got a right angle here. So I can actually go through the process of saying, well, that's C, that's B, that's A, and do a bit of Pythagoras Theorem. A squared plus B squared equals C squared. Now this is not just me torturing you. Pythagoras Theorem comes up a lot. And so we'll change that to a y. And so we actually get from this, we get y squared is equal to 25, 9 plus 16, and y is equal to 5. It's a pretty common Pythagorean ratio. And now I'm going to use that, and this is my opposite. I've got 3 letters there now. Opposite the angle, so I'm dealing with tan. And of course I've got each of them represented here. Tan equals opposite over adjacent. So tan 31 is equal to 5 over adjacent. So I'm going to rearrange this now. I'm going to change that adjacent to x, because that's what I'm trying to find. I get x tan 31 equals 5, and then therefore x is equal to 5 over tan 31. I'm very worried I'm running out of space, so I'll just throw the x equals up here. X therefore equals 5 divided by tan 31, and that is 8.3214 ... which I'm going to round down to 8.32 to 2 decimal places. So there's my answer. Now I should go back and just check, does this make sense? Or it's a tan ratio situation. Am I expecting this to be 8? Certainly doesn't look like it should be 8. But if this is 31, which is not to scale, this one here must be 90 minus 31, which is 59. So I'm expecting the side opposite the larger angle to be bigger. 8.32 is bigger than 5. I'm happy with that. That's a suitable answer. So there's some examples for you. Hopefully you've worked through before me and had a good crack at them and a think about them, because that pretty much covers all the types of questions you can get. Well, thanks for joining me in this video. Don't forget that you really need to understand that sometimes you're finding a denominator and sometimes a numerator. Make sure that you understand both methods. All the best.